Hello, let's continue with the problem we were discussing the last week, CT4 September 2013, question number 3. Let's finish off part 3 and part 4. Okay, just a quick reminder of the question. We have a bus route in a large town, has one bus scheduled every 15 minutes. Traffic conditions in the town are such that the arrival times of buses at a particular bus stop may be assumed to follow a Poisson process. Mr. Bean arrives at the bus stop at 12 midday to find no bus at the stop. He intends to get on the first bus to arrive. Now we have finished part 1 of the question, asks us to define the Poisson process. We finished with that. We have also finished this part in the previous video, where we asked to determine some probability, the probability that the first bus will not have arrived by 1 p.m. the same day. Now let's move on to the next part of the question. Good. Now the first bus arrived at 1:10 p.m. but was full. So Mr. Bean was unable to board it. In part 3 of the question, they ask you to explain how much longer Mr. Bean can expect to wait for the second bus to arrive. This is easy. Okay, this is an easy problem. Let's see what I've written. What is the answer? Good, 15 minutes. Yeah, again, right? You asked to explain how much longer Mr. Bean can expect to wait for the second bus to arrive. The answer is 15 minutes. Why? That's from the memoryless property. So I've written it here. Okay, the answer is 15 minutes. That's from the memoryless property of the Poisson process. Okay, let's move to the last part. Part 4, calculate the probability that at least 2 more buses will arrive between 1:10 p.m. and 1:20 p.m. Okay, take note, between 1:10 and 1:20 p.m. we are looking at a 10-minute time interval. 10-minute time interval. Now we know that our lambda is, from our question here, okay, we know that our arrival rate of the buses, our lambda is 4 per hour. Again, we have our lambda from the information given in the question as 4 per hour. So now we are dealing with just a 10-minute time interval. Therefore, we need a new lambda. Okay, so it's 60 minutes. We have 4. How many arriving in? 10 minutes. So we take 4 times 10 over 60, and you will get 2 over 3. So now your new lambda, let's call it lambda 1, will be 2 over 3. That's for a 10-minute time interval. We are asked to work out the probability that at least 2 more buses. Okay, so we are looking for probability x bigger than or equals to 2. So let's look at my solution. That's what I've done here. We are looking for probability x bigger than or equals to 2. The new lambda is 2 over 3. And remember, probability x bigger than or equals to 2 is 1 minus probability x equals to 0. And you need to minus probability x equals to 1. Again, let's do it here. I have 0, 1, 2, 3, and so on. These are the values that x can take. We are looking for x bigger than or equals to 2. So we can write x bigger than or equal to 2 will be the complement, 1 minus probability x equals to 0 minus probability x equals to 1. That's what you see here. Okay, the formula we're using is e to the power minus lambda x over x factorial. Okay, except that remember the new lambda is 2 over 3. So that's what you see here. Probability x equals to 0 will be e to the power of minus lambda. That's what you see here. Okay, I've used lambda 1 because we're looking at 2 over 3 here instead of 4, which we had earlier. And then probability x equals to 1 okay, will be e to the power minus lambda, lambda over 1 factorial, which is 1. That's what you see here. Lambda 1, e1 raised to the power of negative lambda 1. Again, we have 1 minus e to the power of minus lambda 1 minus lambda 1 times e to the power of minus lambda 1. Now, plug it in, plug in the numbers, you will get 1 minus e to the power of minus 2/3. In brackets here we have 1 plus 2/3. Use a calculator and you will get 0.1443. And we are done.